We've talked about the two types of electric charge, positive and negative, and its source within the atom. We are now going to discuss how charge moves from place to place. Before we get there, we have to talk about the ground. Electrons flow between objects, both conductors and insulators. They can also flow from the Earth, which is an excellent conductor, to the objects, and from the objects to the Earth. Because of its massive size, the Earth serves as the ultimate source and destination for electrons that want to move away from where they are. This concept of grounding will be discussed in much more detail in the electric potential unit of this course, but for now, let's just remember it can both give electrons and it can take electrons, almost infinite amounts of them. When a wire is attached between the Earth, so here's the Earth over here, and here's some object, and let's say this is negatively charged, and we attach a wire, conducting wire from it to the ground, excess electrons will flow to the Earth until this object here is neutral. That is called grounding. If I had positive charge, an excess of positive charges, electrons will flow from the Earth, hang on, I should write Earth here, Earth will flow from the Earth to the positive charged object. When you touch an object with a net negative charge, you may get a shock. This is because the conductor wants to get rid of its excess electrons. Now you are connected to the ground, so the electrons will flow through you to the ground. If the conductor had an excess positive charge, the electrons would flow from the Earth to you. In either case, there is a spark. That can hurt. Note, just for a little historical thing, grounding used to be called earthing many decades ago because of the flow of electrons to and from the Earth. Electrical circuits and devices are usually grounded. That means they have a wire connecting them to the ground. Right here, this is the symbol for a ground, several horizontal lines getting smaller and smaller. You have a wire going up here to this little plug here. Your electricity is flowing through these two plugs, and you plug in your hair dryer or radio or cassette player. Ask your parents what a cassette player is. However, if there's a defect somewhere and electricity leaves the wires, or there's a cut in the wire, or there's something wrong with your equipment, this line will take those excess electrons and bring them down to the ground, as opposed to going through the hair dryer and into your body. Actually, if you get any outlets put in today, you have to have all three of these. In the old days, you would just have two points here to plug your device in. You'd have no protective grounding. But now all new installations have to have a ground wire. You would much rather have charge go to the ground than go through your body.